Good day, madam. I'm Catherine Nonghui, and our member is Chongkesin Simiting and Charlene. In this video, we are going to present our project.
For Part A, I reviewed the paper titled A Review Complete Analysis of the Cache Architecture for Better Performance, published in 2024. This paper discussed the importance of cache memory in improving computer system performance. Cache memory is a small and high-speed memory located between the CPU and main memory that store frequently used data to reduce access time and improving processing speed. The paper explained different cache levels including L1, L2, and L2 cache, and introduced cache hit rate and miss rate as indicators used to measure cache performance. We also reviewed several methods to improve cache efficiency such as victim cache, memory banking, and ECC architecture to increase reliability and reduce error. Overall, I found this paper useful because it provides a clear understanding of cache architecture and how it affects system performance. However, the paper includes limited experimental evaluation and could be improved with more detailed performance comparison.
Good day everyone, I'm Simiting and I will be presenting paper 2 review. This paper focuses on an optimized RISC-V processor that integrates a 5-stage pipeline with a tournament branch predictor to boost processor performance. The authors target control hazard caused by conditional branch instruction, which typically disrupt the smooth flow of execution and degrade efficiency. To resolve this, the tournament branch predictor combines local branch history with global branch outcomes to achieve superior prediction accuracy. Developed in Verilog and simulated using Xilinx Vivado, the architecture was tested with instruction from the RARS compiler. The result shows a massive speed improvement, reaching an instruction per second rate of 2.18 times 10 to the power of 10 compared to 3.93 times 10 to the power of 9 for the traditional branch comparator design. While this practical simulation-driven validation is a clear strength, the paper is limited by using relatively small instruction sets. Future enhancements should involve larger benchmark programs.
My name is Charlene Nalisanade, and I will be discussing the paper 2 review on a study of STT-RAM-based in-memory computing across the memory hierarchy. This paper discusses the issue of traditional computer architecture facing bottleneck due to the movement of data from the main memory to the cache to the processor before computation occurs. So this paper looks at the key concept highlighted, that is the comparison of processing in memory and processing in cache. Also, STT-RAM is discussed because of its useful features such as low leakage power, high density, and non-volatility. What I learned from this paper is that it helps me understand the movements of data between processor and memory and the energy cost and high time that they create. Next, this paper has many strengths, including the fact that it presents the compelling idea that memory can be used for storage as well as supporting computation. Lastly, this paper can improve by providing more visual aids and diagrams and also including more real-world workload comparisons.
I'm now going to present my paper review. This paper begins by emphasizing the crucial role of computer chips, specifically processors. The evaluation is based on several aspects, including key architectural features, processor generations and specification, security and cryptographic features, cache and memory architectures, fabrication process, heterogeneous computing architecture, power and thermal efficiency, cost and interconnection networks. The key findings is the processor roles and capabilities are increasingly converging. Selection should be based on specific application requirement. The strength of the paper is its clear illustration of comparison, and the publication from NDPI indicates that it is highly credible. However, the limitation is it relies on secondary data. For improvisation, they should conduct real-world experiments.
Next, let's introduce SMP Cache. SMP Cache is a trace-driven cache simulation tool used to study and analyze cache memory performance. It allows users to configure different cache parameters such as cache size and mapping methods, and users can observe their effect on system performance. It is widely used as a learning tool because it helps users to understand cache behavior without requiring physical hardware. Looking at our simulation project, we analyzed the miss rate of several trace files using different cache sizes, scaling from 1 to 512 blocks. Overall, the result shows that the miss rate decreases as the cache size increases. For example, Hydro.prg reduced from approximately 66% miss rate at 1 cache block to around 14% at 512 cache blocks. Similarly, NASA7.prg decreased from about 67% to 15%. Among all programs, CXP.prg showed the most significant improvement. Its miss rates dropped dramatically from around 53% to less than 1% when the cache size increased. This indicates that the program has a relatively small working set that fits well into large caches. In conclusion, the simulation demonstrates that increasing cache size generally reduces miss rate and improves overall system performance.
We will now discuss the result of configuration in SMB cache. First, miss rate decreases as cache size increases. This is because it stores more data and instruction, thus fewer memory access is needed. Second, miss rate decrement happens for all trace files. Third, when cache is enlarged, capacity misses decrease. And there is no conflict misses because fully associative cache was configured. Fourth, there are no conflict misses because any memory block can be stored in any cache block. Fifth, the greater the cache size, the more stable the miss rate because majority needed memory blocks are already in the cache. Sixth, the greater difference of miss rate in concrete increment of cache size indicates that significant portion of frequently accessed data fits in the cache. 7. Great difference of miss rate does not appear at the same point for all programs because different program has different memory behavior. In conclusion, increase of cache size improves the performance because more frequently used working set is stored and the properties of cache with faster access.
So what is Git? Git is a version control system that helps to track the file changes and manage project development more efficiently. In this project, we use GitHub as a collaboration platform to manage our repository and group contribution. For the implementation, I have first created the repository and invited all members as collaborators. After accepting the invitation, each member cloned the repository to their local computer using GitHub Desktop. Then, each member opened the member.txt file and added their full name. After making the changes, we saved the file and created a commit with a commit message to record the notification. Finally, the changes were uploaded back to the GitHub using the push origin function. By using Git and GitHub, our group learned how version control helps organize project files, track contribution history, and support collaboration more effectively during project development.
Let's now look at the discussions for GitHub. So, first question, what is Git version control system and who developed it? Git is a free and open source distributed version control system that is designed to handle everything from small to very large projects with speed and efficiency. Linus Torvalds, the creator of Linux, is the person who developed the initial version of Git in April of 2005, and it is now run under the leadership of Junior Hamani. Next, question 2. What is the difference between Git and GitHub? Git is a distributed version control system that is built to help developers track and manage code changes, whereas GitHub is a garage where a team gathers to build code together. Therefore, the difference is Git tracks changes in code, whereas GitHub provides collaboration and project management tools. Next, number 3. What are the key features and benefits of using Git? One of the key features is branch workflow, which is an isolated environment for every change to the user's code base. Next is the distributed development, which is that each developer gets their own local repository with a full history of commits. And last but not least, it has a large community which allows third-party libraries, also allows opening of different source codes and etc. Next, let's look at question number 4. How does Git help facilitate collaboration in team projects, particularly those involving assembly language? Well, Git allows its users to track changes across a team, and besides that, it also allows users to work on separate branches and also merge their work and resolve conflicts. Lastly, question number 5. How does Git version control help us manage project source code, especially in mixed language environments with both low-level and high-level programming languages? Well, Git is able to store and manage all files of all languages in one repository, and the users can use different branches to test how different parts of the system interact with each other. So the changes that are made are logged into Git so users can trace changes and review, test, and revert them if necessary. In conclusion, this project has allowed all our group members to take the initiative to do a lot of self-learning. Besides that, a lot of the research had to be done so as to learn how to operate SMP cache and GitHub. Now, some of the issues that were faced includes finding a suitable paper to review. The paper had to be relevant within the published timeframe of 2000 to 2006 and not too complicated. One area that we can all improve on in the future is implementing GitHub into our daily projects and experiments so as to better our skills in this area. It is important to note that Git is a vital tool that should be used by all programmers so that projects are better maintained and teamwork is achieved.